My name is Jitu Jaswal, and I will be your instructor for this complete training. Okay, let's start first our topic discussion. What topic we will cover in our complete training? Wait. Okay, so we can focus on topic discussion first. Topic discussion first. This training is related with Cisco ASA firewall box. Cisco ASA firewall box. Okay, so this complete training will take minimum 16 to 20 hours. Everyone, can you hear me? Please
Yeah,
type
yes.
please type yes or
Yes,
no
yes, yes.
chat
We
window.
can,
Okay,
we can,
you
we
can
can.
turn off your mic and you can type yes or no
Hello.
on Zoom chat window.
Yeah, yeah, yes, 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 yes.
Okay, so this complete training will take minimum 16 to 20 hours. 16 to 20 hours. What I can provide you, I will provide you slides and notes. So we have proper notes for each topic. Each topic, for example, if I'm discussing about routing concept, NAT concept, we have a proper notes. And I think slides is already shared with you. So we have a slides and notes for each topic. I will share with you EVNG full pack software. EVNG full pack software. In EVNG full pack software, you can get all the images. Like you can do practice for Cisco ASA, Palo Alto, Firewall, Checkpoint, ASA, FTD. You can do any practical. Okay, it's a 70 GB file, approx 70 GB file with all images. You can just download VMware Workstation software. You can upload this EVNG application in VMware. It's required minimum 16 GB RAM. If you want to utilize properly this EVNG software, you need minimum 16 GB RAM in your laptop. Now let's talk about topic discussion. So our first topic is what? Basic configuration. Basic configuration. We can focus on what is firewall device. What is firewall device and why Cisco ASA? Why Cisco ASA? Because in network, we have multiple vendors for firewall device. We have multiple vendor. For example, we have vendor Cisco is a vendor. Cisco is a vendor. In Cisco, we have two type of firewall device, Cisco ASA. This is our training, Cisco ASA firewall device. This is Cisco's second generation firewall device. But yes, we have next generation firewall box option in Cisco. This is called Cisco FTD, Firepower Threat Defense. It's a combination of Cisco ASA plus Firepower. Firepower. This is called Cisco NGFW. We have another vendor, for example, Palo Alto. We have another vendor, for example, Checkpoint firewall device, FortiGate firewall device. So these are top vendors for firewall box. Cisco ASA is not a next generation firewall device. FTD, Palo Alto, Checkpoint, FortiGate, these are called next generation firewall device. But Cisco ASA is a second generation firewall device. Second generation firewall device. It means this firewall can filter traffic based on L3, and L4 information. This firewall can filter the traffic based on L3 and L4 information. It means it can filter the traffic based on source IP, destination IP, and L4 means what? Service or protocol. So first we can discuss about why Cisco ASA firewall device, because in market we have multiple vendors. Why Cisco? What features we have in Cisco ASA firewall box? For example, if I'm working with any Palo Alto engineer, so that I can explain. Yes, we have a lots of features in Cisco ASA firewall box. And we need to know the product family, because if you guys are familiar with Cisco routers, Cisco switches, or any other vendor, so we need to know the product family. Okay, what firewall series we are using for organization. For example, if I'm working in a small network or medium-sized network, or if I'm working in a big enterprise network, which firewall is suitable for my organization. So I need to discuss product family information. Then basic configuration, how to access. In basic configuration, you can focus on how to access Cisco ASA firewall device. And to access Cisco ASA firewall device, we have two options: CLI and graphical page. 90 to 95% configuration you will configure through CLI command. Cisco ASA is CLI based, but yes, we can do some configuration with graphical page. Yes, we can do. We have a lab, but all the configuration will configure through CLI command. So how to access Cisco ASA firewall device through console? How to go with the basic configuration? Basic configuration like backup configuration, interface configuration. See, interface configuration, how to configure our inside interface, outside interface, and DMG network. DMG network. What is DMG network? I will tell you. Okay, in firewall, we have a term of DMG network. Okay, we are familiar with inside network and outside network, but yes, in firewall, in any firewall device, you will get a term. It's called DMG network. I will tell you about this. So we can go with the interface configuration. Interface configuration, we can discuss how traffic is traveling through Cisco ASA firewall device. And this is important topic. If you are working with any firewall box, Palo Alto, Checkpoint, FTD, ASA, okay, so you need to know traffic flow through the firewall device, how traffic is traveling through the firewall box, through the firewall device. You need to know. Now, security level. Yes, we have a concept of security level. Cisco ASA is not a zone-based firewall device, everyone. It's not a zone-based firewall device. If you go with the Palo Alto, Cisco FTD, or Checkpoint, these are called JBF firewall device. Palo Alto, FTD, and Checkpoint. These are called JBF firewall device, zone-based firewall. Into these firewall devices, you can create zones everywhere. You can create zones. For example, LAN zone, WAN zone, and DMG zone. FortiGate is not a zone-based firewall device. FortiGate is not a zone-based firewall device. Cisco ASA is not a zone-based firewall device. Cisco ASA works with a concept is called security level. Yes, we have a concept of security level. After that, we can discuss what is security level, what is security level range. I will tell you. Now, remote management. Remote management, in case if I want to access firewall device, yes, we have an option. We can access box through console page, through console. But in case if I'm looking for remote management, for example, I want to access firewall device through telnet, through SSH, through graphical page. Yes, option is available. You can go with the telnet and SSH option. Routing configuration. Why routing? Why routing with the firewall device? Because routing concept we are using with Cisco routers, right, everyone? Akash, Dushyant, Harshal, Moin.
Yes.
The routing concept we are using, we are familiar with routing concept. Okay, we can use in a Cisco router. We can use in a router device. Why routing in firewall box? Because see, like other vendor, Cisco is giving you option. Like other vendor, okay. For example, you are working in a branch office. So you're working in a small branch office, okay. And you don't have any router. You want to configure routing. You want to configure static routing, default routing, or any dynamic routing method. In case if you want to implement, if you want to configure, option is available. Option is available. You can configure routing, static routing, default routing, RIP, EIGRP, and OSP. Here, I'm not telling you the story. What is static routing? What is RIP? What is OSP of area concept? No, I'm not telling you the story because you guys are familiar with CCNA training. Okay, you have an idea about what is OSP of EIGRP and RIP version 2. Here I will tell you how to configure in Cisco ASA firewall device. Because for different network communication, we need routing concept. Now, what is ACL? After connectivity, you can go with the packet filtering option. Yes, you can go with the ACL concept, access control list. If you remember CCNA training, so yes, this is called packet filtering firewall method. This is called packet filtering firewall method. We can filter our traffic based on source IP, based on source, destination, service, and protocol. Remember CCNA training? In CCNA, we have two type of ACL. Numbered ACL and named ACL. In numbered and in named ACL, you can implement standard ACL and extended ACL. Standard ACL and extended ACL. This is CCNA training. But if you go with the Cisco ASA firewall device, in Cisco ASA firewall device, we don't have this concept. Numbered ACL, no, we don't have this concept. Numbered ACL, you cannot implement. Standard ACL, you cannot implement. If you talk about ACL configuration in Cisco ASA firewall device, you can go with named ACL. You can go with a named ACL. And in named ACL, you can only implement extended access list. So ACL is important. To filter your traffic, to allow your traffic, you need ACL entry. Now, after ACL, it's just like a policy, everyone. Okay, if you go with the other vendor, for example, in Palo Alto, you can say security policy. In FortiGate, you can say firewall policy. In Checkpoint, you can say access policy. In FTD, you can say access control policy. In Cisco, we can say ACL concept. Now, after ACL, we can go with the NAT concept. NAT. What is NAT? NAT we are using for translation, right? We can translate one IP into another IP. And if you go with the NAT concept, CCNA NAT concept, CCNA. So we have three type of NAT implementation: static NAT, dynamic NAT, and PAT. Remember everyone, in CCNA training, we have three type of NAT, right? Akash, Wes,
Yes.
three type of NAT: static NAT, dynamic NAT, and PAT option. What is static NAT? It's a one-to-one mapping. We can map one private IP address with one public IP. It's a one-to-one mapping. Dynamic NAT, in dynamic NAT, we can create a range of public IP. With the help of single command, you can create a range of public IP address. And in PAT, we can translate multiple private IP address with single public IP. So we are familiar with static, dynamic, and PAT concept. And no problem, I will tell you the basic again. Okay, we can revise NAT concept. But in firewall device, if you talk about firewall box, in any firewall device, you can go with two type of NAT implementation. The first one is what? Source NAT. And the second option is what? Destination NAT. You can implement two type of NAT here: source NAT and destination NAT. Now, what is source NAT? In which scenario we can use source NAT? What is the scenario to use destination NAT? We can discuss here. Source NAT and destination NAT. It's a common concept. Story is common. Story is same. If you talk about implementation, yes, implementation task is different in each firewall device. And yes, we have some extra feature in each firewall vendor. But yes, this is the common concept. Source NAT and destination NAT. It's a common concept. After NAT implementation, NAT will take time, okay? NAT will take theoretical and practical implementation. Only this topic will take minimum 2 to 3 hours. Only this topic. After NAT implementation, we can go with advanced ACL configuration. This is called object group. This is not object. Okay? Because if you talk about Cisco ASA firewall box, Palo Alto, Checkpoint, FortiGate, FTD, these are called object-oriented firewall box. object-oriented firewall box. You can create objects here, and these objects we can use in our configuration. These are called object-oriented firewall device. But here, this is not object concept. This is object group. This is called advanced ACL implementation. Advanced ACL implementation. Now, next topic, we can focus on next generation IP implementation. Next generation IP implementation. Yes, we can configure next generation IP. If you are familiar with IPv6, if you are familiar with IPv6 concept, if you know the format of IPv6, yes, we can configure in Cisco ASA firewall box like other vendors, We can also configure routing. We can go with the static and dynamic routing implementation. I will tell you how to configure next generation IP in Cisco ASA firewall box. Now, next topic is layer 2 firewall. Layer 2 firewall. Layer 2 firewall device. So we can use our firewall box. We can use our firewall box in two modes. Either we can use our firewall box as a layer 3 firewall box, or you can say NAT mode firewall device. And we have another option, layer 2 firewall, or you can say transparent firewall device. So we can use our appliance, our box as a layer 3 or as a layer 2. For example, I have a device. If I'm using this device as a layer 3 firewall box, so yes, we can configure IP address on these interfaces. Yes, we can configure IP address on these interfaces. It's a L3 firewall box, so we can configure routing, we can configure NAT, we can configure VPN, and we can also utilize firewall feature if I'm using this box as a layer 3 firewall box. In case if I'm using this complete box as a layer 2 firewall, as a transparent firewall device. So these interfaces, these interfaces are called L2 interface. I'm not talking about switch port. Naveen, can you hear me? Naveen, I'm not talking about switch port. Okay, it's not a switch port.
Yes, sir.
Okay,
I can hear you.
it's an interface. Okay, it's not a switch port. Okay, but it's a L2 interface. It means we cannot configure IP address on these interfaces. These are called L2 interfaces.
But that won't work as a span port.
Sorry, trunk.
Span port. No,
Talking about trunk port, Naveen?
no, not about span port. Span port. It's
Span.
a
No,
yeah,
span is a different concept. Okay.
yeah. No. I'm
Port analyzer.
incorrectly like as a L2 port and span port. I'm just trying to understand.
No, we are not using this interface as a span port, Naveen. Okay. These are called,
Okay.
see, span is a concept, switch port analyzer. Okay. This concept you can use in, it's a L2 and L3 device feature. You can implement in L2 device in L3 box. Okay, here I'm
How does
telling
that?
you
Yeah.
if this box is acting as a layer 2 firewall, it means these interfaces are called L2 interfaces. L2 means what? We cannot configure IP address on these interfaces. Clear my point?
Yes. Yes.
But it's not a switch port. It's not a switch port. Okay, it's a layer 2 firewall. It's a layer 2 interface. It means we cannot configure IP address on these interfaces. It's a layer 2 firewall box, everyone. So we cannot configure routing here. No, not possible. NAT, no. VPN, no. We cannot configure routing, NAT, and VPN.
How does this port will
So
work?
in this,
Like
yes, Naveen,
how does this port will
your voice is
act as
not
a
clear. Can you repeat your question again?
how does this port will work in actual environment?
I will tell you. Okay, the scenario where we can use layer 2 firewall box. I will tell you the scenario. Okay, right now I'm giving you the basic idea.
Hello. Yeah.
I
Yeah.
mean, right now I'm giving you the basic idea.
Hello.
Clear now?
Okay. Okay. Yeah.
Okay. Now please turn off your mic. If you have any question, you can unmute. Now, so we can use this firewall box as a layer 2 firewall box, as a transparent firewall device. It means we cannot configure IP address on these interfaces. We cannot configure routing into this box. NAT, no. VPN, no. So the point is, in this scenario, we can use this complete box as a layer 2 firewall. In this scenario, because we have limitation, everyone. With a layer 2 firewall, we have limitation. If I'm using this complete box, my point is, if I'm using this complete box as a layer 3, yes, I have a great feature. I can configure IP address on interfaces, I can configure routing, NAT, VPN, I can utilize firewall feature. But in case if I'm using this box as a layer 2, yes, I have limitation. So in this scenario, we can use our box as a layer 2 firewall box. I will tell you. Okay, but yes, right now, yes, I'm telling you, we have a topic, layer 2 firewall. Layer 2 firewall. Now let's go with the topic. Wait. In layer 2 firewall, first we can focus on basic initial configuration. Basic initial configuration in layer 2 firewall box. Basic initial configuration. How to configure access policy, because it's a firewall. It's a layer 2 firewall, but it's a firewall box. To allow your traffic, you need to configure access policy, ACL. We can configure ACL in L3 firewall box. We can configure in L2 firewall box. Yes, option is available. We can also go with Ether type ACL implementation. Ether type ACL you can configure when your device mode is in transparent firewall box mode, or your device mode is layer 2 firewall box mode. You can go with the Ether type ACL. So these are the points we can discuss. These are the points we can discuss in layer 2 firewall. Now, okay, now our next topic is about how to configure logical interfaces. Logical interfaces. Remember, we have logical interfaces in Cisco router, in Cisco switches, like loopback interface, everyone. Loopback interface, right?
Yes.
Ether channel. Ether channel, it's a logical interface. VLAN interface, it's a logical interface. So like other vendor, yes, option is available in case if you are looking for Ether channel configuration. Yes, you can configure. This is called port channel here. Yes, you have a new topic, red interface. Red interface option is not available in Cisco router, in Cisco switches. No, we have a red interface configuration. So these two are logical interface configuration. We'll discuss what is the scenario to use port channel and red interface. After logical interface configuration, we can go with virtual firewall concept, or you can say security context. We have a same topic. We have same topic in FortiGate firewall scenario, same topic. In FortiGate, you can say, in FortiGate firewall scenario, you can say VDOM concept. It's a common topic. In FortiGate, you can say VDOM. In Palo Alto, you can say virtual system. In Cisco ASA firewall box, you can say VDOM and security context. You can divide your single firewall box. What is security context or virtual firewall? You can divide your single firewall box into multiple virtual firewall box. For example, we have one Cisco ASA firewall device. Cisco ASA firewall device. This firewall box is connected with LAN side portion. This is your LAN side portion. In LAN side portion, we have multiple departments. For example, okay, we have marketing department, sales department, and HR department. Okay, we have multiple department, marketing, sales, and HR department. In case In case if I'm looking for separate departmental control, for example, I want to configure separate type of access policy, NAT policy, VPN configuration, other configuration in each department. Or you can say for marketing and for sales, I'm looking for dedicated layer 3 firewall box. And for HR department, I'm looking for dedicated layer 2 firewall box. So into this scenario, what you can do? Into this scenario, you can go with 3 separate physical appliances. You can go with 3 separate physical appliances. And if I'm going with 3 separate physical appliances, then what about cost? What about cost? So that's why I'm not going with the 3 separate physical appliances. What I can do, I can buy a single big box. And with license, with the help of license, we can divide our single firewall box. We can divide our single firewall box into multiple virtual firewall box. I'm not going with the 3 separate physical appliances. I can divide my single firewall box into 3 virtual firewall box. For example, I'm creating marketing firewall box, sales firewall box, and HR firewall box. So first, you can divide your single firewall box into multiple virtual firewall box. After that, you can assign your resources. Resources means what? Your interfaces are called resources. Interfaces are called resources. For example, a fast Ethernet 0/0, fast Ethernet 0/1, 0/2, 0/3, 0/4, 0/5. So first you can divide your single firewall box into multiple virtual firewall box. After that, you can assign your resources. These are called security contexts. Okay, what you have? Marketing context, sales context, HR context. Now marketing traffic. Now this time, marketing traffic is traveling via marketing firewall box. Sales traffic is traveling via sales firewall box. HR traffic is traveling via HR firewall box. And there is no communication. There is no any communication in between these firewall devices. And for this, you need to buy license. You need to install license in your box for security context topic. And in our training, yes, we are using license device. Okay, you can create security context. Now, our next topic is a common concept, failover. In Cisco ASA, you can say failover. In Palo Alto, you can say high availability. In Checkpoint, you can say clustering concept. In FortiGate, you can say high availability. In Cisco FTD, you can say failover concept. So what is failover concept? For example, I have a firewall box. I have a firewall device. This firewall is connected with LAN side portion. Okay, this side is ISP side network. Okay, we have a LAN interface, WAN interface. Okay, I'm using proper IP address configuration 192.168.10.1/24, 99.99.99.1/24. So my point is you have a firewall box. Okay, you have a firewall box with all configuration. We have a proper configuration into this box. Interface configuration, routing configuration, NAT configuration, ACL configuration. You can say traffic is traveling. You can say traffic is traveling through the firewall device. But into this design, into this topology, we have single firewall box, everyone. We have single firewall box. In case if this box goes down, if this box goes down, then your LAN user, they cannot go on internet side. They cannot access internet resources. So you have single firewall box. Into this scenario, you can go with high availability concept. You can go with backup firewall box concept. You can add one more firewall device. You can add one more firewall device into this design. This is what firewall box 2. This is firewall box 1. So you need to add one more firewall device into this design. Why? For failover, for high availability. If you are adding one more firewall device into your design, So let's change this topology. Okay, we have a layer two, we have a switch. This is switch number 2. This is switch number 1. This is ISP portion. This is LAN side portion. So second firewall box I'm using for failover. And in Cisco ASA firewall box, everyone, in Cisco ASA firewall box, in Cisco FTD firewall box, you can configure failover only in between two firewall box. In Palo Alto, you can configure failover only in between two firewall devices. But if you go with the checkpoint, if you go with the FortiGate in a single high availability cluster, you can add 8 firewall devices in a single high availability cluster. But in Cisco ASA, in FTD, in Palo Alto, you can configure high availability only in between two firewall devices. Okay. So you can compare now. Okay. You can compare high availability topic in each vendor. So now my point is what? Here we have firewall box 2. Firewall box 2 I'm using as a backup firewall device. This concept I'm using for failover concept. And in failover, we have two mode. We have two mode option, active standby, and we have active option. What is active standby? This is failover mode, high availability mode. In between firewall box 1 and firewall box 2, we are using a link. This is called high availability link, or you can say failover link. So now in case if you are working with active standby scenario, one firewall is actively manage your traffic. Okay. And second device status is what? Standby firewall device, or you can say passive firewall box, passive firewall device. All the traffic is traveling via this active firewall box. All the traffic traveling via active firewall box. Through this failover link, through this HA link, firewall box 1 is sending a hello packet to firewall box 2. Okay, he's saying hello, I'm active. Hello, I'm active. So firewall box 2 status is standby. Firewall box 2 status is what? Standby. So traffic is traveling through active firewall box 1. In case if this box goes down, in case this box goes down, then firewall box 2 will take the responsibility, because firewall box 2 is not getting any hello packet through this failover link, because firewall box 1 is not available. So firewall box 2 is not getting any hello packet information from firewall box 1. So this box can get an idea. Firewall box 1 is not available. Now let's change mode. And now I'm active firewall box. And traffic is automatically traveling via this box. Automatically. Firewall box 2, everyone, firewall box 2 is a copy of firewall box 1. It's a copy. Okay. It's a copy of firewall box 1. If you are configuring interfaces, routing configuration, policy configuration, all the configuration will replicate through this HA link. Okay, so firewall box 2 is a copy of firewall box 1. You cannot utilize because firewall mode is standby. If active box goes down, then second firewall box will become active and traffic is traveling via firewall box 2. Akash, clear here?
Yep.
Okay. So in active standby, we can utilize only one firewall box in our high availability cluster. We can utilize only one firewall box. But in case if you want to utilize all the firewall device in your high availability cluster, then you can go with active scenario. We can go with active failover. And this lab is called active with multi-context. Active with multi-context. What is context? Virtual firewall. What is context? Virtual firewall. We can divide single firewall box into multiple virtual firewall box. So active lab we can do, but with multi-context. Let me tell you the scenario. I'm giving you the basic idea right now. For example, this is box 1. Wait. For example, I have box 1. Okay, and this one is box 2. So this one is box 1. This one is box 2, and we have a LAN switch. LAN switch, for example, we have marketing department. Okay, we have sales department. So now we can connect a cable here. So first we can divide our single firewall box into two virtual firewall box. I told you, failover you can configure only in between two firewall devices in Cisco ASA, in Cisco FTD scenario. So first we can divide in active scenario. First, we can divide our single firewall box into multiple firewall box into two firewall devices. So I can divide in marketing, sales. Second box, marketing and sales. So in active scenario, we can utilize both the firewall devices. So into this scenario, for marketing team, this box 1 is a active, and box 2 marketing is what? Is in a passive state. For sales department, box 2 status is what? Active. And box 1 sales is status is what? Passive. So for marketing department, box 1 is an active firewall box. Box 2 is a standby. For sales department, box 2 is an active and box 1 is what? Passive. So we are utilizing both the firewall devices. Yes, Akash, any question?
Yes. Can we do load sharing on
No,
Cisco?
no. This feature is not available.
This is only for load balancing in Cisco.
See, this is not a load balancing.
Okay.
This is not a load balancing. Okay, load balancing feature you can use in FortiGate.
Mm-hmm.
In FortiGate, this load balancing feature is not available in Cisco ASA firewall device. This is not a load sharing. Okay,
Okay.
we are dividing our firewall box. You can
Okay.
say,
Separate.
you see what you are doing. You are trying to utilize both the firewall device.
Mm-hmm.
Okay, this is not a load sharing.
Okay.
What is load sharing? For example, if you remember GLBP, remember GLBP
Yeah,
concept?
I remember GLB.
GLBP, they can share the load. They are using a default load balancing method round robin, right?
Yeah.
Equal load sharing.
Yes.
Okay, but this is not HSRP, VRRP, GLBP. Okay.
No,
We,
I'm talking in the perspective just like as you remember in Palo we have a part like one firewall can do layer 4 to layer 7, one firewall can do layer 2 and 3 like that. So I'm just curious about that. Like
no,
is there possibility?
load balancing feature is not available. Okay.
Okay. No worries, it's fine. Thank you.
Now, everyone, let's take a break for 5 minutes. Akash, Devanshu, Dushyant, Harshal,
So
Moin, Naveen.
Uh, yes, before that, I have one question. I want to understand why do we want to use active in multi-context? What will be the purpose of using active in
In
multi-context?
case, if you want to utilize both the firewall device, otherwise active standby is a popular option. Active standby is a popular option for any firewall device, for any next generation firewall device. Is a popular option. In case if you want to utilize both the firewall device, you can go with active. Clear my point? But see, active behavior is different in each vendor. Everyone, Dushyant,
Yeah.
active feature is different in each firewall device. Here, what you are doing? Here you are trying to divide your single firewall box into two virtual firewall box. So for marketing, for box 1 is active. For sales, box 2 is active. Okay. If you go with the active scenario in Palo Alto or in FortiGate, so concept is different. Concept is totally different if you go with the active. Here, what we are doing, here we are trying to utilize both the firewall device, but we have a concept with multi-context. If you go with the FortiGate, for example, you have multiple firewall device, 4 firewall device. So, for example, this is firewall box 1, firewall box 2, firewall box 3, firewall box 4. If you talk about active concept in FortiGate, so one device will act as a controller. Dushyant, okay? One device will act as a controller. Firewall box 2, firewall box 3, firewall box 4. These are copy of firewall box 1. We have same configuration, firewall box 2, 3, 4, 5, 6. We have same configuration. Here we are using load sharing. All the traffic will go and hit on this controller firewall box. Then this controller firewall device will share load with each firewall devices. This is the activity concept in FortiGate.
Okay.
But if you go with the Cisco ASA, you are trying to utilize both the firewall devices. So we have active with multi-context. Clear now? Without multi-context, you cannot implement active.
So which device is going to make a decision, which traffic going through which
I will tell
firewall?
you the difference, okay? I will tell you in detail, okay?
Okay, sure.
Right now, I'm giving you the basic idea. We have a topic. We have
Okay.
active standby is a topic. Active is a topic.
I have one more question. Sorry to
Sure,
disturb you.
sure.
Is there any kind of model specific to that? Like if I want to make a Cisco ASA 5410 is a Cisco ASA with the same pair like in Palo, we can create HA with the 220 and 220 only. We can't create any other model. So
Yes. Requirement is same, Akash, okay? We need same hardware model.
okay.
We need same hardware model. We need same Cisco ASA version. Same set of licenses is required for high availability configuration. Yes.
Okay. Thank you.
Okay, everyone, let's take a break, okay, for 5 minutes. It's a 6:45, okay. We can take 5-minute break only. We will continue at 6:50, okay. Please turn off your mic. Everyone can hear me. Everyone can hear me. Can we continue our topic now? Everyone,
Yes, sir.
can we continue our topic now?
Yep.
Yes.
Okay.
Yeah.
Okay, so next topic we can focus on deep packet inspection. Deep packet inspection. Cisco ASA is not a next generation firewall device. No. Cisco ASA is a second generation firewall device. So this firewall can filter traffic based on L3 and L4 information only. Okay, this firewall cannot detect application, cannot detect viruses, cannot detect malicious link. No. But we have a small concept in Cisco ASA. This is called deep packet inspection. Yes, firewall can do deep packet inspection. What is deep packet inspection? In deep packet inspection, you cannot detect application, virus, or malicious link. No. In deep packet inspection, this Cisco ASA firewall device can inspect protocols, can inspect protocol behavior. For example, you can inspect FTP protocol. You can inspect a DNS protocol here. What is inspection? First, we can focus on what is deep packet inspection concept. I will tell you, okay, I will tell you what is deep packet inspection. And yes, we have a default global policy. We have default global policy for deep packet inspection. It's a predefined policy in Cisco ASA firewall device. We have a default global policy for deep packet inspection. We'll discuss the concept. We'll discuss the policy configuration. Once you complete your global policy concept, this is default one. But in case if you are looking for custom policy, for example, you want to do deep packet inspection, you want to inspect FTP protocol, DNS protocol, HTTP, HTTPS protocol, you can create your own custom deep inspection policy, or you can say MPF concept, modular policy framework. So we can go with the global policy, default global policy we can discuss first. We can create our own deep inspection custom policy. So we have a small concept, deep packet inspection. Okay, this is not a next generation firewall feature. Your firewall can inspect only protocol. Now, next topic is what? It's a common concept like NAT. Like NAT, it's a common concept, VPN implementation. VPN implementation. First, we can discuss about what is VPN, virtual private network. We'll discuss about what is the feature of VPN, what is the benefit of feature, what is the benefit of VPN concept, what is encryption, hashing, Diffie-Hellman. If you talk about implementation, so we have two type of implementation here. We have two type of implementation. The first option is IPsec, IPsec VPN, and second option is SSL VPN. IPsec we are using for site to site VPN connectivity. What is site to site VPN connectivity? For example, you have two branch office. You have two branch office, for example, branch office A and branch office B. You want to connect these two branch office over this public network, in a secure manner if you want to connect. So you need to establish a tunnel first. You need to establish a tunnel here. This is called what? Site to site tunnel. This is called site to site VPN tunnel. And for site to site VPN tunnel configuration, we can go with IPsec option. IPsec. This concept is called IPsec site to site VPN. What is IPsec? What is IPsec phase 1? What is phase 2? What is phase 1 protocol? What is phase 2 protocol? We will discuss in detail. Okay, we'll discuss in detail IPsec site to site VPN implementation. In site to site, you can connect branch office. Okay, you have one branch office in Noida, one branch office in Mumbai. You can connect with site-to-site VPN tunnel. We have one more type of VPN implementation, and this is called remote access VPN. Remote access VPN. In remote access VPN, your outside user, you can say home user, you can say remote user, you can say this outside user, he's trying to access company private resources, for example. For example, this portion is your DMG network. What is DMG network? I will tell you, okay? I will tell you what is DMG network. So here, what we have DMG network. In DMG network, we have servers, and these servers are publicly allowed for outside user. My point is, this outside machine, remote user machine, he's trying to access company private resources over this public network. Okay, he has a simple Wi-Fi modem at his home. You can say he has an internet connectivity. This outside user is trying to access private resources. So he need to establish a connection first. He need to establish a connection first with his mobile phone, laptop, desktop. And once this connection will establish, then yes, this outside user can access private resources. This type of connection is called remote access VPN connection. Remote access VPN connection. And once this connection is established, this connection is an encrypted connection, secure connection. No one can decrypt. For remote access VPN implementation, we have two options. You can configure remote access with IPsec or you can configure with SSL. SSL is a popular option. Why? Why SSL is a popular option? I will tell you. I will tell you the difference in between IPsec and SSL. SSL is a popular option. For site-to-site, IPsec is a popular option. But for remote access, SSL is a popular option, secure socket layer. In SSL, we have two type of implementation for remote access VPN. The first one is clientless SSL VPN. In clientless SSL VPN, outside user can establish his connection with any browser, Google Chrome, Mozilla Firefox, with any browser. We have one more type of VPN implementation. This is called full client SSL VPN. In full client SSL VPN, this outside user need to download and install VPN client software. For example, in Cisco, we have Cisco AD Connect. In Fortinet, we have OT client. In Palo Alto, we have Global Protect. In Checkpoint, we have mobile application. In Cisco FTD, we have Cisco AD Connect. So this VPN topic, my point is this VPN topic will take minimum 4 to 5 hours. Site-to-site implementation and SSL remote access implementation. Now we can discuss how to access Cisco ASA firewall device with graphical page. Okay, I told you Cisco ASA you can manage through CLI option or with the graphical page. Cisco ASA 90 to 95% configuration with the we can configure with the CLI command. But if you go with the Cisco FTD, I'm just giving you an idea. Okay, Cisco FTD is a next generation firewall device. If you go with the FTD, 99% configuration, you can only configure with the graphical page. CLI option is not available. CLI option is not available. If you go with the Palo Alto, yes, you can do some configuration with the CLI. We can go with the graphical page. 90% configuration we can configure with the graphical page, Palo Alto, FortiGate, Checkpoint. But FTD, in 99% configuration, you will configure through graphical page. CLI option is not available. Okay, so in Cisco ASA, yes, we can access. Cisco ASA, yes, we can access with the graphical page. And for graphical page, we can download and install one application, Cisco ASDM software. ASDM software application you can download and install. You can install in management PC. You can connect your firewall device with management PC. You can configure one IP address here. Same series of IP you can configure into this management PC. You can download and install ASDM software. Through ASDM, you can access. Through ASDM, you can access Cisco ASA. You can manage Cisco ASA firewall device. If you go with the Palo Alto, you can do all your configuration with the browser. If you go with the FortiGate, you can do all your configuration with the browser. But if you go with ASA, you need ASDM software. If you go with FTD, Firepower Threat Defense, then you need a separate appliance, FMC, Firepower Management Center. If you go with the checkpoint gateway, if you want to manage checkpoint gateway, yes, you need checkpoint management. You need checkpoint management to utilize all the features, to configure all the features. You need FMC to configure all the feature of Cisco FTD. But if you go with the Palo Alto, if you go with the FortiGate, you can manage these two firewall devices. You can do all configuration through browser. Cisco ASA, you can manage only through ASDM. Clear my point, everyone? Rupesh? Rupesh,
Yeah.
clear?
Yeah.
Okay, so this is our topic discussion, everyone. Topic discussion. Okay, let's start our first topic. And before start first topic, let's talk about firewall box first. Okay, I'm not talking about Cisco ASA. I'm not talking about Cisco ASA or any firewall or any vendor. I'm talking about simple firewall term. What do you think about firewall? Can anyone help me? What do you think about firewall device, everyone? What do you think about firewall box? Can anyone try?
Yeah, device which filter traffic based on rules we have given.
Filter based on IP, source IP, right?
Yeah.
Destination IP, service or protocol. Any
Yep.
other idea? Any other idea about firewall box? Any other idea? Okay, no problem. See. So what is firewall device, everyone? Firewall is just like a router. Remember always. Firewall is just like a router. In router, we can configure routing, right? No problem. You can configure in firewall box. In router, you can configure NAT. No problem. You can configure in firewall device. In router, we can configure VPN. Yes, you can configure in firewall device. So firewall is just like a router. Any firewall device. Firewall is just like a router. But yes, in firewall, we have some advanced feature which router cannot provide you. Yes, we have some advanced feature. Now, firewall. What is firewall? Firewall is a system, you can say, or group of system that can manage access between network. Between network means what? LAN network. We are familiar with LAN network, WAN network, and DMG network. What is LAN network? Your private network portion. Your private network portion is called LAN network. What about WAN network? Your public site network. Your internet side portion. Public network. Your internet side portion is called what? Public. WAN side network. So we are familiar. We are familiar with LAN side portion. We are familiar with WAN side portion. What is DMG? Any idea? What is the requirement of DMG network? OS, can you hear me, dear? Yes, Akash. What is DMG network? Any idea? Okay, no problem. Let me tell you. See, we are familiar with LAN network and WAN network, right? For example, I have a firewall device. I have a firewall device. Any firewall. I'm not talking about Cisco ASA, any vendor. I have a firewall device. Now this portion is your LAN side portion. LAN side portion. So what I'm doing, I'm putting all my devices. I'm putting all my devices in LAN side portion. This is switch. For example, I have web server, company web server, company DNS server, company SMTP, company FTP server. This one is what? web server, SMTP, DNS, FTP. Yes, we have some end devices, laptop, desktop servers, and we have some company confidential servers. These are company confidential servers. So I'm putting all my devices. My point is I'm putting all my devices in LAN side portion. This is your LAN side network. Now this portion is called ISP side portion, ISP side network. ISP side network. This is called WAN side network. Now into this design, for example, if I want to allow some traffic from WAN side network from outside, I want to allow some traffic from outside. So yes, we need to configure policy because it's a firewall box. It's a firewall box. If you are working with any firewall device, to allow traffic, you need to configure policy. Okay, so I want to allow some traffic. For example, this outside machine can access web server, company web server. So to allow this traffic, we need to configure policy. For example, in Cisco ASA, I will configure ACL. In Palo Alto, I can configure security policy. In Checkpoint, I can configure access policy. So I can configure rule. And in policy, I can add two information, L3 information and L4 information. I can define source IP, I can define destination IP, I can define service or protocol. So I can add source IP, destination IP, service and protocol. After that, I can take action. I want to allow some traffic. So based on policy, my point is, based on policy, traffic is traveling from outside to your inside network. Yes, this outside machine can go and hit on firewall device, and then can go to this web server, no problem, because of your firewall policy. But the point is this traffic is initiated. This traffic is coming from WAN side network. This traffic is initiated from WAN side network, initiated from untrusted network. Untrusted network. Internet is what? ISP portion is what? Untrusted network. So traffic is coming from untrusted network. Now it may be possible this traffic is trying to compromise. Yes, this outside machine can access this web server because of your policy configuration, but it may be possible this traffic can try to compromise your other devices. Because traffic is coming from untrusted network. Clear my point, everyone? Can try to compromise your other devices because traffic is coming from untrusted network. That's why what we are doing, into this design, what we are doing, we are trying to put these servers. These servers, FTP, DNS, web server, we are trying to put, wait. Okay, so we are creating a separate network. For this, we are creating a separate network. This network is called DMG network. Just a name, everyone. DMG, demilitarized zone, it's just a name. You can give your name, my name, no problem. It's just a name. DMG, it's just a technical term. So I can create a separate network. It's called DMG network. And here I can put all these servers. For example, company web server, SMTP server, DNS server, FTP server. Okay, so because these servers are publicly allowed. These servers are publicly allowed for outside users. So I can put these servers in a separate network. This is called DMG network. DMG network. Now this time traffic is coming from outside, no problem. Traffic is coming from outside. Traffic will go and hit on this WAN facing interface. And as per your configuration, your firewall will redirect this traffic on web server. As per your configuration. How to redirect our traffic, we'll discuss. We have a topic destination NAT implementation. I will show you how to redirect our traffic. So when traffic will go and hit on firewall public facing interface, as per your configuration, your firewall now will redirect this traffic on web server, will redirect on DNS, SMTP, FTP. Now, into this scenario, your LAN portion network is secure now. Clear this point where we need DMG network? In DMG network, we can put our servers, and these servers are publicly allowed for outside user. Clear now my point? Everyone? Please type yes or no in chat window. Okay. Now let's talk about some other term in firewall device. Other term. So next point is what? Stateful firewall inspection. Stateful firewall inspection. It's a common concept. It's a common concept for any firewall device. It's a common concept for any firewall device. What is stateful firewall inspection? So I have one firewall box. I have Cisco ASA firewall device. Yes, we are working with Cisco ASA. Cisco ASA firewall device. Cisco ASA firewall box it will work with a concept is called security level concept. Security level. So I have Cisco ASA firewall device. Okay, I'm connecting one interface with LAN side network, your inside network. Now this portion is your ISP side network, outside network, you can say. Okay, interface, we have fast Ethernet 0/0, fast Ethernet 0/1. So in Cisco ASA firewall device, if you go with any interface, for example, this interface, fast Ethernet 0/0, if you go with any interface, and if you type this predefined keyword, INSIDE, if you type this predefined keyword, inside keyword, INSIDE, if you type this predefined keyword on any interface in Cisco ASA firewall device, this interface will get a security level. This interface will get a security level 100. Cisco ASA firewall device works with a concept is called security level. Security level. So this interface will get automatically security level 100. Security level 100. Now, if you go with this interface, fast Ethernet 0/1. Okay, on this interface, you can type anything, not inside, anything. Your name, my name. For example, I'm using outside. I'm using this keyword outside. So automatically this interface will get a security level 0. So we have a security level range in between 0 to 100. Is in between 0 to 100. Now into this design, this inside machine, 192.168 10.10 machine, for example, he's trying to communicate with this outside server 8.8.8.8. Why we are creating this topology, everyone? Our topic is stateful firewall inspection concept. As I said, it's a common concept for any firewall device. Okay, now, so this 10.10, my point is this 10.10. This 10.10 is trying to communicate with 8.8.8. So this traffic will go and hit on firewall interface. Will hit on firewall interface. When traffic will hit on firewall interface, firewall will verify this interface security level is 100. Okay, no problem. Now this inside machine is trying to communicate with 8.8.8. And it's a part of outside network. So traffic is trying to travel through the firewall device. Traffic is trying to travel through the firewall device. And in Cisco ASA firewall box, in Cisco ASA firewall device, by default, traffic is allowed. By default, traffic is allowed from higher security level to lower security level. No need to configure any firewall policy. No need to configure any firewall policy. By default, traffic is allowed. By default, traffic is allowed from higher security level to lower security level. By default. So now traffic is trying to travel from higher security level to lower security level. Yes, as per default concept, traffic is traveling to outside. Traffic is traveling to outside. And when traffic is traveling through the appliance, when traffic is traveling through the firewall box, then this firewall will maintain the state of connection. This is state of connection in a table. This table is called state table. State table. Firewall will maintain the state of connection in a table is called state table, or you can say connection table, or you can say session table. And what it maintained in a state table, it maintained source IP, source port number, destination IP, destination port number. So as per our task, 192.168.10.10 is a source IP. 10.10 is source IP. Source port number, everyone. It's a random port number. For example, 52,000. Destination IP, 8.8.8.8. Destination port number, for example, is trying to access web services, port number 443. So traffic is traveling. When traffic is traveling through the firewall device, firewall will maintain the state of connection in a table. This is called state table or session table, or you can say connection table. Now, what about reply packet now? What about reply packet? When 8.8.8 will send a reply packet, this reply packet will go and hit on firewall device. Will go and hit on firewall interface. And this interface security level is what? 0. This traffic will go and hit on firewall interface, and this interface security level is 0. Okay, so what about reply packet? Reply packet will go and hit on this interface. This interface security level is what? 0. Now traffic is trying to travel from lower security level. Traffic is trying to travel from lower security level to higher security level. As I said, traffic is allowed from higher security level to lower security level. Traffic is allowed. Traffic is allowed by default. But if traffic is trying to travel lower to higher, everything deny. Everything deny in Cisco ASA firewall device. Now, when reply packet, my point is, when reply packet will go and hit on firewall interface. So when any traffic, everyone, when any traffic will hit on firewall, any interface, firewall will check this traffic information in a state table. Is there any entry available for this traffic? So firewall can verify now traffic is coming from 8.8.8. Yes, I have an entry. And this 8.8. is trying to communicate with 192.168.10.10. So firewall can verify entry is already available in session table, in a state table. It means it's not a new connection. No. The traffic, firewall can verify traffic was initiated from inside network. This is not a new traffic. Because when traffic is traveling through the firewall device, then firewall will maintain a state of connection in connection table. When traffic is traveling through the firewall device. So now firewall can verify based on state table. Firewall can verify this is not a new traffic. No, this is not a new traffic. Because in state table, in connection table, we have information. The traffic was initiated from inside network. So it's just a reply packet. It's not a new traffic. It's just a reply packet. So based on state table information, firewall can allow this traffic. Firewall can allow this reply packet. And this concept is called stateful firewall inspection. What is a stateful firewall inspection? When traffic is traveling through the appliance, through the firewall box, then firewall will maintain the state of connection in state table and then forward the traffic to the outside. When reply packet will come, firewall will check this traffic information in state table. If entry is available, traffic is allowed. If not, traffic drop. Clear my point, everyone? Devanshu, Dushyant, Harshal, Moin,
Yes,
Vipin,
sir.
Wes.
Yeah.
This is called what? Stateful firewall, okay? And this is not just a story, okay? You can verify state table information in any firewall device if you want, any firewall device. In Cisco ASA, you can type show connection to verify your state table. I can show you state table information. State table information. Wait, everyone, 2 minutes.
Okay.
Okay, now let's talk about next concept, next common concept for any firewall device. This is called firewall mode. Firewall mode. Firewall mode. We can use our firewall device in two mode. If you talk about any firewall device, we can use our firewall device in two mode. Either we can use our firewall box as a layer 3 firewall box, or you can say NAT mode firewall box. We have another option, layer 2 firewall box, or you can say transparent firewall device. So in case if I have a firewall box, if I have a firewall device, and this box I'm using as a layer 3 firewall box, as a NAT mode firewall device. So these interfaces are called L3 interfaces. We can configure IP address on these interfaces. We can, just like a router interface, everyone, we can configure IP address on these interfaces. We can configure routing here, NAT, VPN we can configure, and we can also utilize firewall feature. But in case if I'm using this box, this complete box as a layer 2, as a transparent, so these interfaces are called L2 interface. It's not a switch port, it's a L2 interface. It means we cannot configure IP address on these interfaces. We cannot configure routing here, no. Routing, no. NAT, no. VPN, no. But yes, we can utilize firewall feature. So the point is, in this scenario, we can use our complete box as a layer 2. Because if you go with layer 3, if you go with the layer 3 mode, we have great feature. We have great feature in firewall device. We can connect our firewall device with internet directly. We can do translation. We can terminate VPN connections. But in case, if I'm using this complete box as a layer 2 firewall box, I have limitation. So the point is, in this scenario, we can use our complete box as a layer 2 firewall box. Let's talk about scenario. Let's talk about scenario. For example, I'm working in an existing routing switching design. Okay, I have one L3 device, router device. This portion is ISP side portion. ISP side portion and wait. ISP side portion. This side is your LAN side network. LAN side network, you have some computers here. LAN side portion. Into this design, everything is working fine. Okay, into this design, everything is working fine. Okay, this inside machine can send traffic to the switch. Switch is forwarding traffic to the gateway. And based on routing table, router is forwarding traffic to the outside. Everything is working fine into this design. Okay, this is your LAN portion. This is what your LAN portion. This is what your WAN side portion. So now into this existing design, my point is, into this existing design, I want to deploy a firewall box into this existing design. So yes, I'm trying to deploy a firewall box here. And this firewall box I'm using as a layer 3 firewall box. I'm using as a layer 3 firewall box. If I'm using this box as a layer 3, so these interfaces are like L3 interfaces, just like a router interface. It means each interface will participate in different subnet, right, everyone? Just like a router interface, each interface will participate in different subnet. Now your single subnet is divided into two portions. Different network, Yes or no? Everyone, clear my point?
Yeah.
Each interface will participate in different subnet, in different network. No problem. I want to deploy a firewall box here. No problem. I can do this. I can change existing IP address scheme here. No problem. I can change, I can deploy, I can utilize this firewall box. But in case, if I don't want to change anything into this existing design, and I want to deploy a complete firewall box. So I can use this complete box as a layer 2 firewall. My point is, into this live network, I don't want to change anything, but I want to deploy a complete firewall box, complete next generation firewall box, complete firewall box. So I can use this box mode as a layer 2. Layer 2 means what? These two interfaces are L2 interfaces. They are the part of same subnet. It means no need to change existing IP address scheme. No need to change existing IP address scheme. We have a single subnet this time. And yes, it's a firewall device. So we can define this is inside network. Okay, this one is outside network. We can give a name. We can give a description. It's a firewall box. If you want to allow traffic from inside to outside, yes, you need to configure policy. It's a firewall box. But yes, we cannot configure routing now. We have a limitation. We cannot connect ISP connection with this layer 2 firewall box. We cannot configure IP address, NAT, and VPN. But yes, we can deploy our complete box as a layer 2 firewall box. Clear this point, the scenario? In a live network, where I don't want to change anything. I don't want to change any IP address scheme, but I want to deploy a complete firewall box. So I can use this box as a layer 2 firewall box. I can use this box as a layer 2 firewall box. Clear now, everyone? This mode you can use, okay, most of the time, okay? This mode you can use in existing data center network. Okay, if you are working in a complex data center network, in your data center network, you want to deploy your firewall box. For example, you have 20 firewall box today. You want to deploy 20 firewall box in your existing data center network. Then if I'm using this box as a layer 3 firewall box, I need to change existing IP address scheme in our complex data center network. It's not possible. It's a difficult task. And I want to deploy a firewall box so that into this scenario, I can use this firewall box mode as a layer 2 firewall box. Then there is no need to change any IP address scheme. You can deploy a complete box as a layer 2 firewall box. Clear this scenario? Clear, everyone?
Yeah.
Okay, now. Now let's focus on Cisco ASA firewall box. Let's focus on Cisco ASA. Wait. Cisco ASA firewall device. Cisco ASA. Cisco ASA is what? Adaptive Security Appliance. ASA means what? Adaptive Security Appliance. ASA firewall box. It's a second generation firewall device. It's not a next generation firewall device. Okay, if you are in future, if you want to learn Cisco FTD, this ASA training can help you. Because Cisco FTD, Cisco next generation firewall device, it's a combination of Cisco ASA and Cisco Firepower. So if you are familiar with Cisco ASA, yes, you can work with Cisco FTD. So Cisco ASA, it's a adaptive security appliance. It's a full form. We have a lots of feature in Cisco ASA, a lots of feature. I can explain to any firewall administrator. For example, my colleague is working with Palo Alto. I can explain some feature. So yes, we have a lots of feature here in Cisco ASA. Let's talk about each feature one by one. Our first feature is what? Operating system. Operating system. Okay, if you have any idea about checkpoint, for example, if you have any idea about checkpoint firewall device, in checkpoint, we have Gaia operating system. Checkpoint is what? It's a software-based firewall device. It's a software base. You can go to checkpoint website. You can download this free operating system, Gaia operating system. This operating system you can install on any machine. You can install it in your laptop, in your desktop, in your server machine. Okay, you can use your laptop, desktop, server machine as a complete firewall box. Yes, you can use. So in Checkpoint, you can buy operating system from Checkpoint website. You can install any hardware. If you face any issue with the hardware, you can talk to vendor. If you face any issue with operating system, you can talk to Checkpoint. But if you talk about Cisco ASA, both hardware and software belong to Cisco. Both hardware and software belong with Cisco. If you have any issue with hardware, you can talk to Cisco, single vendor. It's not like other vendor. Okay, they have different company OS and another company hardware. Like Checkpoint is an example. So hardware and software both belong to Cisco. This is the first benefit. Second is what? Stateful firewall. I told you, stateful firewall inspection method. It's a common concept. It's a common concept for any firewall device. What is stateful firewall inspection? What is stateful firewall inspection? It maintains the state of connection when packet is traveling for the appliance. It maintains a state of connection in state table. After adding information in state table, it forward the packet to the destination. When reply packet will come, it match the packet. Information in state table. If match, packet accepted, otherwise drop. Yes, Cisco ASA firewall device has stateful firewall inspection method feature. Now, next feature is called what? User-based authentication. Yes, like other vendor, you can go with user-based authentication. You can go with AAA implementation here. You can use AAA implementation method for telnet services, for HTTP, HTTPS, and FTP. You can go with user-based authentication method. Next feature, you can go with protocol and application inspection. What is protocol and application inspection? So yes, we have a topic, deep packet inspection, or you can say MPF topic, modular policy framework. Modular policy framework. I told you. Cisco yes, Moin. Moin, any question?
No.
Okay. So Cisco ASA is not a next generation firewall device. Okay, this firewall cannot detect application, malicious link, viruses, no. But yes, this device can inspect protocols like FTP, SMTP, DNS, TFTP, HTTP, NetBIOS. For example, I'm working with SMTP protocol. I'm working with SMTP. So to run SMTP, 15 to 17 command instruction is required in background to run this SMTP protocol. For example, if attacker will add some malicious code in SMTP protocol, SMTP traffic, then this command instruction will increase. For example, this command instruction is now 40 to 45. So if you enable deep packet inspection, your firewall can verify SMTP traffic, command instruction 45. This is not a normal behavior. This is not a normal behavior because default is what? 15 to 17 and now 40 to 45. It means there is a malicious activity. So firewall will drop this traffic. This is called what? Deep packet inspection. So we can discuss protocol and application inspection. Firewall can do. Cisco ASA can do. Can we take a break, everyone, for 5 minutes?
Yes, yes, sure.
5 minute break. Okay.
Okay.
So 7:35. We will continue at. Let's take a 5 minute break only. We can continue at 7:40. Please turn
Okay.
off your mic.
Can we make it 10 minutes?
Sure. We can continue at 7:45, everyone.
Thank
Okay.
you.
Please turn off your mic. Hi everyone, can you hear me? Akash, Dushyant, Harshal,
Yes, yes, you're audible.
Moin. Okay, let's continue our discussion now. Okay, so next feature in Cisco ASA firewall device, Cisco ASA firewall box support VPN implementation. We can configure IPsec, we can configure SSL option. Cisco ASA firewall device, we can divide our single firewall box into multiple virtual firewall box. So this is Cisco ASA firewall feature. Same concept we have in FortiGate firewall box. Same concept. In FortiGate, you can say VDOM. We can divide our single firewall box into multiple virtual firewall box. In FortiGate, you can say VDOM concept. In Cisco, this is called what? Virtual firewall, or you can say security context. Next, in Cisco ASA firewall device, next feature is what? Web-based management. Yes, like other firewall devices, you can access your Cisco ASA firewall box with graphical page. For graphical access, you need to download and install ASDM software. ASDM application you need to download and install. Next feature in Cisco ASA, we can implement failover. We can implement failover. We can go with active standby. We can go with active failover. Let me show you Cisco ASA firewall box first. Wait. Let's go with the basic concept. Okay, so I have a simple design. Okay, I have one Cisco ASA firewall device. Let's talk about basic configuration first. I have one Cisco ASA firewall device and one router. Simple topology. One router and one Cisco ASA firewall box. You can connect a cable. You can connect a cable. Interface Ethernet 0. For example, this is your inside router. I can add outside and DMG network. So let's start the Cisco ASA firewall device first. You can right click and start. Right click, you can start router. This is Cisco ASA firewall console page. This will take time, okay? Please wait. It will take time. So to access Cisco ASA firewall device, we have same option. Like how to access Cisco router or switches. You can access through console cable. This is console page, everyone. Now, once you access your Cisco ASA firewall device, this is console page, everyone. Everyone can hear me? Everyone?
Yes, you are
Okay,
audible.
now. So this is Cisco ASA firewall box console page. Now you are in user exec mode. You can type enable command here. You can press enter. Asking for password. There is no password. You can press enter. You can press enter now. you are in privilege mode. So once you log in your Cisco ASA firewall device, you can use your first command, show firewall. I want to verify firewall mode. So this firewall mode is layer 3 firewall. Firewall mode is what? Router. It means this is layer 3 firewall box. You can use next command, show mode command, to verify security context information. Security context information. So this firewall security context mode is single. So this is single firewall box. This is single firewall box. If you want to change this firewall device in multi mode, you can go in global configuration and you can type a command mode multiple. We'll discuss, okay? But this is the command. Right now, this firewall box mode is security context mode is single mode. You can type show version command here to verify hardware information, license information. See, we are working with Cisco ASA Adaptive Security Appliance software version 9.x. 9.x operating system, 9.1. You can see here we have ASA 5520. This is hardware platform 5520. Let's talk about hardware platform here. Wait. Okay, so this is what Cisco ASA firewall hardware model series. Okay, like if you go with the Cisco router, so we have some entry-level routers, we have some distribution layer routers, we have core layer routers. So in Cisco ASA firewall device, we have a series. We have series Cisco ASA 5505. This model we can use. This is called entry-level firewall device. This model we can use in a small network, small office or branch office. For example, I'm working with 50 computers. Okay, 60 computers, 100 computers. You can go with Cisco ASA 5505. You can go with Cisco ASA 5510 for small office, branch office, 5512, 5515. Now, you can see here, we have 5505 Cisco ASA model. We have Cisco ASA 5506X. X. Okay, if you have this symbol X with any ASA model, it means this is Cisco ASA firewall device with firepower feature. Cisco ASA firewall device with firepower. With firepower. If I'm saying firepower, it means this is not a Cisco next generation firewall device. No. If I'm saying only firepower, Cisco firepower, this is called NG-IPS. Next generation intrusion prevention system. This is NG-IPS device. This is not a Cisco next generation firewall device. No. So Cisco ASA 5506 with X, it means this is Cisco ASA with firepower feature. It means you can buy firepower module. You can install into the Cisco ASA firewall box. You can get you have a slot here. Okay, you can install this Cisco firepower. You can also utilize ASA with firepower feature, NG-IPS feature. Okay, with X option. So we have hardware model. These are hardware model 5515, 5520. 5520 we are using for medium-sized network. For large deployment, we can go with 5550, 5540. Now we have for data center network, for data center or for large deployment, you can go with 5585X. 85X. Like other vendor, everyone, like other vendor, like Palo Alto, FORTINET, Checkpoint, like other vendor, Cisco ASA firewall device is providing, Cisco ASA firewall is providing physical appliance. Physical appliance, it will provide VM firewall box. VM firewall box. Both options are available. You can go with the physical appliance or you can go with the VM firewall box. VM firewall box we are using in a virtualization scenario. For example, we are working with AWS, Azure network, or EXXI network, VMware network. So you can go with VM firewall box. Okay, if you have Cisco ASA only, Cisco ASA, this is physical appliance. If you have Cisco ASA with a small v, this is not a physical appliance. No. This is what? Complete Cisco ASA firewall device. But this firewall device we can use in a virtualization network. So we have Cisco ASA module. So like other vendor, Cisco is also giving you option. You can go with the physical appliance. You can go with the VM firewall box. So right now into this, into this topology, we are working with Cisco ASA 5520, medium size firewall device. We have RAM, CPU information. Now here you can get license information also. So we have license for active. We have license for active. Without license, you cannot configure active passive or active lab. You cannot perform. We have license for DES and triple DES. It means we can configure VPN concept here. We have license for security context. It means I can divide this single firewall box into 20 virtual firewall box. I can divide. So you can verify license information here. Now let's verify show interface information, show interface IP brief command. Here we have show interface IP brief command. So we have 4 interfaces here, everyone. Right now, we have 4 interfaces. For example, I want to configure inside interface, Ethernet 0. I'm using as an inside interface, inside network, IP address 200.200.0/24. So Ethernet 0, I'm using as an inside network. Ethernet 1, I'm using as an outside network. For example, 10.1.23.0 network. So Ethernet 1, I'm using as an outside network. Now Ethernet 2, I'm using as a DMG network. 10.1.32.0/24. So I'm trying to configure firewall interface, everyone. Firewall interfaces. Let's go to the Cisco ASA firewall box. Cisco ASA firewall box. Now, interface Ethernet 0. Let's go to the global configuration mode. Command I can use interface Ethernet 0. So first you can type nameif command. With nameif command, you can define your description, okay? Remember I told you we have predefined keyword here. In Cisco ASA firewall box, we have predefined keyword. This is called inside keyword. Okay, I'm using what? INSIDE. Inside keyword. If you go on any interface and if you type this predefined keyword inside, INSIDE, if you press enter, this interface will get a security level 100 automatically. See, security level for inside set to 100 by default. Now you can configure IP address. So IP address 200.200.200.1 mask. No shutdown command. Yes, you can use no shutdown. Exit. I'm trying to configure interface Ethernet 1. So interface Ethernet 1. Nameif. So I'm not using inside keyword. Okay, you can use any keyword, any name here. For example, I'm using outside. It's just a name. Everyone, outside is just a name. You can type anything here. You can type your name, my name, no problem. So nameif inside, you can press enter. So I'm not using inside keyword, okay? You can type anything. If you press enter, you can see you are getting security level for outside interface is set to 0 by default. So higher number is what? 100 and lower number is what? 0. IP address, yes, I can configure IP address 10.1.23.1 mask, no shutdown. I have one more interface. Interface Ethernet to name if I'm using what? DMG network. DMG, you can press enter. You can see security level is what? 0. Security level is 0. So into this design, we are using security level 100 here. Security level 0 here. Now on DMZ side network, I'm using security level 50. So you can verify here how to change security level on any interface. If we have a command, security level, you can type question mark. You can select a number in between 0 to 100. For example, I'm using 50. Now we can configure IP address 10.1.32.1 as per our design. Mask. Now no shutdown. Now you can verify. Show command you can use in Cisco ASA firewall device, everyone. Show command we can use in any mode. Okay, if you are working with Cisco router, remember Cisco router. If you are working with Cisco router, you need to go in privilege mode, then you can type show command. Otherwise, you can use do option. In Cisco ASA, show command you can use in any mode. For example, I'm in interface mode, I can type here. Show interface IP brief. Yes, we have 3 interfaces, Ethernet 0, Ethernet 1, Ethernet 2. We have 3 interfaces. You can use this command, show name if. So we have 100 security level number on inside interface. We have 50 security level number on DMZ interface, Ethernet 2, this interface. We have security level 0 on outside interface on Ethernet 1. Clear how to configure interfaces? Akash, Devanshu, Dushyant, Harshal, Moin.
Yes, clear.
Yeah,
Your name is Navista, right?
it's N Vashish, Nitesh Vashish. So you can say Nitesh. That would be
Okay, Nitesh. Okay.
Yeah.
Okay.
Yeah.
Wes, can you hear me? Rupesh, clear? Moin.
All good.
Okay.
Yes, we can.
Now, so
Yes, all.
so here we have interface. We have IP address on interfaces. You can verify, show interface IP brief. We can verify. We have IP address configuration on interfaces. Now let's go to the router. Okay, wait. Let's go to the inside router. I'm working with only 2 devices, one router and one Cisco ASA firewall device. Now, let's configure IP address to this inside router. Please wait. Now, interface Ethernet 0, 0/0, 200.200.200.10. Same series of IP I'm configuring on router interface. Now, no shutdown. Let's verify our connectivity. So I'm trying to verify my connectivity from this router to this firewall Ethernet 0 interface. I'm trying to verify my connectivity to the firewall, not through the firewall. I'm talking about to the firewall. So ping command, ping 200.200.200.1. This is firewall Ethernet 0 interface IP. Trying to verify my connectivity and I'm getting reply. I have a connectivity because it's a directly connected interface, same subnet of IP. I have a reachability. If I have a reachability, so if I'm trying for telnet service, then if I'm trying for telnet service, 200.1, I cannot access. See, because telnet is not enabled by default in Cisco ASA firewall device. If you are working with Cisco router, you will get a message here, password not set. It's open, but password not set. But here you cannot get any message here. You cannot access. Telnet is disabled. In Cisco ASA firewall device, you can go to Cisco ASA, you can type telnet command. Telnet command. Here you can define IP address of the host, IP address of the host or network authorized to log into the system. So here you can define specific or trusted IP address information. Only specific IP or specific subnet can access this Cisco ASA firewall device. For example, 200.200.200.0 complete network. Complete network can access this. Complete subnet can access Cisco ASA firewall device. So I can use mask here. Mask. Now this 200 is a part of inside network. So if you type question mark, you can define your interface information. So this 200 is a part of inside network. You can press enter. You can press enter. And now you can set a password. Password. For example, password CCIE 12345. Now let's try for telnet this time. Password. Password is what? CCIE 12345. Yes, you can access. See, Cisco ASA firewall device. Now, if you talk about SSH, then so we have same configuration step like Cisco router. We have same configuration step for SSH configuration. SSH configuration. What is SSH? Secure step. Why we are using SSH? Why we are using SSH secure cell? Because telnet is a clear text communication. Telnet will provide you clear text communication. SSH will provide you encrypted communication. So for remote management, SSH is a popular option. SSH is a popular option. So how to configure SSH? So we have same command syntax, just like a Cisco router. Command syntax is what? You can give a host name first, like Cisco ASA, Cisco ASA firewall. Now you can use a command domain name. In Cisco router, command is what? IP domain name. In firewall, domain name. Domain name, I'm using cisco.com, for example. Any name you can define. Now command for SSH crypto key generate RSA. You can just press enter. You can just press enter. And now you can create username because if you remember for SSH, you need username and password. You need username and password. So I'm creating username here. Username, user1, for example. User1, password, user1, privilege 15. What is privilege 15? So I'm giving full access. In Cisco router, we have privilege level from 0 to 15. 15 is a higher level of access. So I'm giving privilege 15. This user can do anything. So once you create your username, now like telnet, you can use a command SSH question mark. You can define IP address of the host or network authorized to log into the system. So here I have a network 200.200.10. This time I'm creating specific IP entry. This time I'm creating a specific IP entry. Otherwise, you can create You can add complete subnet information. You can add. This time I'm trying to add specific IP. Only this specific IP can access this firewall device through SSH. So for this specific IP mask, I can use 255.255.255 for specific IP /32. Now this IP is a part of inside network. Done. Done. You can type one more command, AAA authentication SSH console what? Local database. This local is what? It's a database. Why I'm using this command? I'm telling what? For authentication SSH. For authentication SSH, please use local database. Why? Because in local database, we have one user account. So I'm saying, please use local database. You can press enter. And this time I'm trying to access SSH on router. If you remember command is what? SSH space -L question mark login name. So login name is username is user1 question mark IP address of a remote system. So 200.200.200.1. Yes, I can access. See, password user1. Yes. Akash clear. Dushyant, Harshal, Moin, Nitish, Uwais,
Yep.
Rupesh. This is what?
Yes.
Telnet and SSH implementation.
I have one question though.
Sure.
When we are typing command, we are mentioning after IP address, we are mentioning the what do we say?
Name of
Security level.
security level. Yes.
Yeah, after the IP address and we enabling, we are mentioning security level like inside. So are we specifying that this IP should come from this interface only or the security level only like that?
See, you're talking about the security level, right?
No. If you scroll down,
Mm-hmm.
you had specified, yeah, for this SSH.
Okay, you're talking about SSH. Yes, only this specific IP can access. No,
And
only
when,
this specific IP can access this firewall device through SSH. Let me try. Wait. Let's try.
no, my question was, we are also mentioning that inside keyword, right?
Inside keyword, because this subnet is a part of inside network. This IP is a part of inside network as per our design. See.
And suppose if we are specifying any IP which is not part of our firewall interface. So in that case, what do we have to specify?
No one can access. No one can access.
Okay.
You need to specify. Okay, this subnet is a part of which interface? Inside, outside, or DMZ. You need to specify. This is command syntax.
So if I want to access from the outside interface from the internet, so what would be the situation then?
You want to access your firewall device from internet.
Yeah.
So you can access through this public IP. You need a static public IP on public facing interface.
Oh, okay.
It's a fixed public IP.
Okay.
Now you can, if you have a connectivity with your public IP, yes, you can access from outside. No problem.
Understood.
But you need fixed public IP.
Understood. Thank you.
Yes. Now, so this is what our Telnet and SSH implementation. Now let's talk about it. Let's talk about this concept. So here we have security level 100. Here we have security level 0. Here we have security level 50. As I said, by default, traffic is allowed from higher security level to lower security level. By default. It means by default, traffic is allowed from 100 to 50. traffic is allowed by default from 100 to 0, higher to lower. By default, allow from 50 to 0, higher to lower. But anything from lower to higher, deny. Lower to higher, deny. Now, in case if I have one more interface, here I have one more interface. This one is a DMZ1, and this one I'm using as a DMZ2. Okay, this is Ethernet, for example, Ethernet 3. So can I use same security level number on multiple interfaces? For example, I want to use 50 security level on Ethernet 3. What do you think, everyone? Can I configure? Is it possible? Is it possible to configure same security level number on multiple interfaces? Yes, it's possible. Yes, it's possible. You can configure multiple. You can use same security level number on multiple interfaces. No problem. You can configure. Okay. Now the point
Then
is,
what's the point of using the same security number on different interfaces?
I'm telling you. Give me two.
Okay.
I'm telling you. Okay. So here we have a scenario. We have same security level. Why I'm creating same security level? I want to tell you one point. See, as I said, by default, traffic is allowed from higher security level to lower security level. This is default concept. 100 to 50, allow. 100 to 0, allow. 50 to 0, allow. But in case if I have two interface with same security level number, I can configure, no problem. If I have two interface with same security level, my point is, can they communicate with each other? Because as per by default, higher to lower is allowed. But here we have same security level number.
By default, I think it's not allowed, but there is a command, if I remember correctly, same security traffic or something permit.
Thank you so much. Thank you so much. Yes.
Yeah, right, sir, right?
Yes, thank you so much.
Thank you.
So here, yes, by default, traffic is not allowed with same security level member. By default. If you want to allow, yes, you have a simple command, one line command. I will tell you. But by default, it's not allowed. Okay. So if you have same security level on multiple interfaces, by default, traffic is not allowed. Now let's go with the next implementation, and let me create a design. Please wait. I'm creating a separate design for the routing implementation. Give me 2 minutes. Give me 5 minutes, everyone. Okay.
So
Everyone, please try to set up the lab on your laptop. If you face any issue, you can discuss with me tomorrow. Try to download this EVNG full pack software. Try to download. I already shared with you Cisco ASA slide. Let me show you. Cisco ASA slides and notes. Okay. Okay, so I shared with you EVNG full pack software. This is EVNG full pack software. We have all the images here. All the images, router, firewall, switches, all the images we have. Okay, you need to download and install VMware Workstation software first. After that, you can import. This 68 GB file. This is a single EVNG file, 68 GB file. You can import in VMware Workstation. Are you guys familiar with EVNG software? Are you guys familiar with EVNG
Yes.
software? Yes.
Yeah.
So you can just upload, if you have EVNG software in your laptop, just upload Cisco ASA image. If you don't have, I can share with you. Otherwise, try to download this EVNG full pack software. Okay, here you can get all the images pre-installed, all the images. Okay, now let's create a design. I'm creating this design for our next implementation, routing implementation. Okay, wait.
Oh, man, so the खत्म हो गई battery?
Yes, any question, Nitish?
Yeah, no, sir, sorry. Yeah.
Okay, I'm creating loopback interface on each router. So 1.1.1.1/32 on R1 for routes. 2.2.2.2/32. Okay, on DMZ router. One loopback I'm creating on outside router This wait 3.3.3. Okay, let's try to configure IP address first. As per our design, I'm trying to configure IP address on router devices first, inside router, DMG router, and outside router. Wait. After that, we can go with the Cisco ASA firewall device. Host name inside, interface Ethernet 0/0. 200.200.10. So I'm using .10 on each router. .10 on each router. So 200.200.10. No shutdown. Let's go to DMG site router. Interface Ethernet 0/0. 10.1.32.10. Mask. No shutdown. Let's go to outside router. This R4 I'm using as an outside router into this design. Host name is outside. Interface Ethernet 0/0 as per design. 23.1 10 I'm using 255.255.255.0. No shutdown command. Let's go to Cisco ASA firewall box. Cisco ASA firewall box. Now host name ASA firewall. Let's try to configure interfaces, everyone. Interface Ethernet 0. Name if inside 200.200.1. So on each interface, in firewall, on each interface, I'm using .1. 255.255.0, no shutdown. Let's go to interface Ethernet 1, name if outside 10.1.10.1.23.1 mask, no shutdown. Interface Ethernet 2, name if DMG, security level I'm using 50, IP address 10.1.32.1, mask, no shutdown. Show interface IP brief. So we have proper IP address configuration. Okay, you can verify your directly connected router connectivity. 200.200.200.10. Ping 10.1.23.10. Ping 10.1.32. So you have a reachability with your directly connected router, but you don't have connectivity with loopback interface. Ping 1.1.1. Success rate is 0%. Success rate is 0%. Now let's try to configure routing into this design. And I'm trying to focus on static routing, default routing, and dynamic routing. Dynamic routing. In dynamic routing, we can focus on RIP, EIGRP, OSPF protocol. Everyone, can you hear me? Can we revise our basic routing? Please help me. Okay, into this topology. Wait. Please help me. I have R1 router, R2 router, R3, R4, R5, R6. In case if I have source here, source, this side I have destination. So to reach from this source to this destination, we have multiple routes. For example, via this side I'm using static routing. Via this side I'm using RIP protocol. Via this side I'm using OSPF protocol. This side we have a speed 10 Mbps. This side we have a speed 100 Mbps. And this side we have a speed 1000 Mbps. Which one is the best route and why?
Static route
Static, why?
because of the AD value.
AD value, right? Whenever router will take routing decision to reach any destination, router will check AD value first, right? AD value first. Static routing AD value is 1. So least AD value, more preferred. And if there is a tie in between AD value, then tiebreaker is protocol metric. Protocol metric. Okay, now let's try to implement routing into this design. Routing. So I'm trying to focus on static and default routing configuration first. Static and default routing configuration first. Into this design, I'm trying to configure static routing for inside network, static routing for DMZ network, static routing, and for outside network, I'm using default route. I'm using default route. Okay, let's go to the router first. So from inside DMG and outside router, okay, from routers towards firewall device, I'm using default routing. Okay, from routers towards firewall device, I'm using default routing. Okay, because our focus is not to configure static and default routing on routers. No, our focus is on how to configure static and default routing in Cisco ASA firewall device. So on routers, I'm using default routing, simple default routing. What I'm saying, for any unknown destination, 200, 200, 200.1 is the next hop IP. Let's go to the DMZ router. Okay, for any unknown destination, 10.1.32.1 is the next hop IP. From outside router, to reach any destination, any unknown destination, 10.1.23.1 is the next hop IP. Now let's go to the firewall device. This is our task. Let's go to the firewall device. This is our task. How to configure static and default routing. So for static and default routing, before configure static and default routing, let's verify our routing table information. So yes, we have only directly connected network information. 200, 200, 200 is directly connected. 10.1.23.0 directly connected. 10.1.32.0 directly connected. So we have only directly connected network information. Okay, let's try to configure static and default routing as per our task, as per our design. So we can go in global configuration mode. What is command syntax? Command syntax is route. Command syntax is what? Route. And now you can type question mark. So you can first specify interface, your exit interface. So I want to configure static routing for inside network. So I can define exit interface. Exit interface. So now destination, remote destination is this R1 loopback interface. This is a remote destination. So remote destination is 1.1.1.1. This is remote destination mask. And what is next hop IP? 200.200.200.10. Done. Done. Let's go for DMZ router entry. So route DMJ 2.2.2.2 mask /32. Next hop IP 10.1.32.10. Now route outside any network towards outside router. I'm trying to configure default routing. So for any unknown destination, for any unknown mask, next hop IP 10.1.23.10. You can press enter, no problem. Or you can go with this format. For any network, you can use single zero. For any mask, you can use single zero. And now you can type next hop IP 23.10. 23. Done. Done. You can verify your routing table information. Show route. Yes, we have an entry. To reach this 1.1.1, 2.2.2, yes, we have an entry, static entry. And to reach any unknown destination, we have a static and default routing. Default routing entry. You can verify your connectivity, no problem. You can verify your connectivity from firewall device. Ping 1.1.1 this time. I'm trying to verify my connectivity with 1.1.1 loopback. Okay, let's check loopback interface. Show IP interface brief. Okay, I don't have loopback interface. Give me 2 minutes. Loopback interface 1.1.1.1 mask. Show IP interface brief. Let's verify on DMZ router. Show IP interface brief. Let's create loopback interface here. 2.2.2.2 mask. Now let's go to R3 DMZ router. Oh wait. No, let's go to the outside router. Outside interface loopback 0. 3.3.3.3 mask. Now we can verify our reachability. Let's go to the firewall device. I'm trying to verify my connectivity with 1.1.1. I'm trying to verify with 2.2.2. Ping 3.3.3. Clear, everyone? Clear this point? Can we take a break for 5 minutes? 5 minutes.
Sure.
Okay, it's a 8:36. We can continue at 8:41. Okay, please turn off your mic. Everyone, can you hear me? Akash, Dushyant,
Yes.
Huh.
I need your one help, small help.
Sure.
Actually, I have installed your evng.ova file. It seems like devices are not starting. Do I need to do any specific thing to start the devices, like any kind of mapping or something?
You can share your screen right now. I can help you. Akash.
Just a second. Actually, I'm using in my different laptop.
Okay.
Let
See,
me. Yeah.
you can wait. You can first.
Mhm.
You can start your EVNG software.
Okay.
You can start your EVNG.
Mhm.
You will get an IP address here.
Yeah. Yep. That I have done.
Okay. So this IP you can type. My point is this IP you can type in browser. So once you type this IP address in browser, now you can right click and go to Node. You can type ASA. You can add a device. You can add a device. You can right click. You can right click.
Yeah, that I have done.
And to access this Cisco ASA our device, you need to download and install EVENG client pack software.
Actually, that I have another EVNG which I'm briefly using it. That's working fine. I am just want to use your EVNG version. So I tried Cisco ASA. So it's stuck on that starting, not even that's not prompting for that CLI. So just blink that blue icon and it just get stopped.
I can help you after session.
Okay.
If you want to
No,
connect,
sure.
if you want to connect, or if you want to connect tomorrow before session, I can help you. Okay.
Okay, no problem. Sounds good. Thank you.
Everyone, let's continue our topic now. Everyone, can you hear Rupesh, Uvesh, Nitesh, Moin, Harshal, Dushyant? Okay, now. So, okay, so let's go to the Cisco ASA firewall device. My point is you can check your routing table, show route. So you have route information. You have route information. Let's go to the inside router. Let's go to the inside router. And you can verify your routing table. So for any unknown destination into this router, for any unknown destination, firewall is my next home. So I have a default route towards firewall device. And firewall has a routing towards DMG, towards ISP. Firewall has a routing. So in case if I'm trying to initiate my traffic from inside, okay, I'm trying to initiate my traffic from inside. I'm trying to travel through the firewall device into this design. In case I want to travel through the firewall device. So as I said, by default, traffic is allowed from higher security level to lower security level. By default, traffic is allowed from higher security level to lower security level. No need to configure any policy. So my point is, in case if I'm trying to communicate, if I'm trying to verify my connectivity with 23.10 from this inside router, I'm trying to verify my connectivity with outside router. We have a routing information, okay? When you initiate this traffic will go and hit on firewall device. It's L3 firewall box. Firewall can check, okay, you want to reach particular destination. Let me check my routing table. Is there any entry available? Firewall has a default route towards ISP gateway. So in case if I'm trying to initiate my traffic, what do you think, everyone? Traffic is allowed or not? What do you think?
But from inside to outside?
Yes, from
Inside
higher
to outside?
Should
Yeah,
be.
sorry.
Mhm.
Outside to inside by default is not allowed.
Mhm.
And from inside, yeah. From high security to low, I think the traffic can flow.
Okay. What about others, everyone?
Yeah, I think the same. It should be allowed from
Allow,
higher.
okay, perfect. Let's try. Okay, let's try. I'm trying to verify my connectivity with 10.1.23.10. Traffic is not traveling. See, I'm not getting reply. Success rate is 0%. As per our default concept, by default, traffic is allowed from higher security level to lower security level, no need to configure any policy. Okay, by default, traffic is allowed from higher to lower, but you can see you cannot communicate. So higher to lower traffic is allowed. Yes, higher to lower traffic is allowed, but only TCP and
Yes.
UDP traffic.
It's a
Remember?
ICMP packet, ping.
Yes, thank you so much.
Ah,
SMP packet, yes.
okay.
Only TCP and UDP traffic is allowed from higher security level to lower security level. Remember always. That's why I want to show you. Only TCP and UDP traffic is allowed. This is what? Ping traffic, ISMP traffic. ISMP traffic is not allowed. But in case, okay, let's go to the outside router. And I'm trying to enable telnet. Wait. Line VTY 024, password Cisco 123. Login, transport, input, telnet. Now, so I cannot ping. Because it's a ISMP traffic. From higher security level to lower security level, traffic is allowed, but only TCP and UDP traffic. So I cannot ping. But in case if I'm trying to access telnet, I'm trying to access telnet 10.1.23.10. I can access because it's a TCP traffic. Telnet is what? It's a TCP traffic. Password we are using Cisco 123. See? So traffic is allowed from higher security level to lower security level, but only TCP and UDP traffic. Only TCP and UDP traffic. Now traffic is traveling, everyone. Traffic is traveling through the firewall device. And if you guys remember our discussion, if traffic is traveling through the firewall device, then firewall will maintain the state of connection in connection table, in a state table. So let's go to the firewall device. Right now, traffic is traveling. Let's go to the firewall device. If traffic is traveling through the firewall device, so we have information in state table, in session table, in connection table. So you can verify show connection. You can verify this command, show connection. You can press enter. You can see we have state table information. Source IP, yes, 200.200.200.10. Source port number, any random port number. Destination IP 10.1.23.10. Destination port number is 23. Destination port number is 23. Here we have a flag UIO. What is UIO? Wait. What is UIO? So you can type show connection. You can type show connection detail. And you can verify what is UIO. U means what? U means up. IO. I means what? Inbound data. And O means what? Outbound data. So now you can verify show connection table. Yes, we have a connection entry because traffic is traveling through the firewall device. Now, if traffic is not traveling through the firewall device, then if traffic is not traveling, now you can check show connection table. Traffic is not traveling through the firewall device. So you can see we don't have any information in connection table. We don't have any information in connection table. Clear now my point, everyone?
Yeah.
Now let's go to the firewall device. Here we can verify we don't have any connection table information. Connection table information. If I'm trying to initiate my traffic again Cisco 123, traffic is traveling. Again, I can verify. Yes, I have information in connection table because traffic is traveling through the firewall device. When traffic is traveling, firewall will maintain the state of connection in connection table. Exit. You can verify again. Show connection. No information. So higher to lower traffic is allowed by default. By default. In case if you are trying to initiate your traffic from outside, for example, from lower security level to higher security level, for example, Let's go to the inside router. Line VTY024, password CCIE123, login, transport, input, telnet. So now you can try now. I can try to initiate ping traffic. Ping traffic 200.200. .200.200.10. I cannot communicate. Okay. I'm trying to initiate my traffic from higher security level to, from lower security level to higher security level. I cannot ping and I cannot access telnet. 200.200.10. I cannot access. Now let's go to the topic static and default routing. So this is what our static and default route entry. Show run route command you can use. You can see you have entry for static and default routing. Okay, now I'm looking for dynamic routing implementation. Let's delete this entry. So in case if you want to delete entry, you can use no command. You can copy this configuration, you can paste here, no problem. In case if you want to delete all your entry in with a single line, you can use a command clear configure route. If you want to delete all your static route entry with single line command, so you can use this command syntax clear configure route. I'm trying to delete all the command with this keyword route keyword. Now you can check show route, show run route, no entry. So let me delete the routing information. Wait. Routing information. And I'm trying to configure RIP protocol. Let's go to R4. Now show IP route. So we don't have any entry. Okay, let's try to configure RIP protocol here, everyone. So inside router RIP version 2, 200.200.200.0. We have one loopback interface 1.1.1. No auto summary command. DMG router. Command syntax is very simple for RIP configuration in Cisco router. Router RIP version 2, 10.1.32.0. We have one loopback 2.2.2.2. No auto summary. Let's go to outside router. Router RIP version 2 network 10.1.23.23.0 network 3.3.3.3 no auto summary. Done. Let's go to the firewall device. We have same command syntax in Cisco ASA firewall device. There is no difference in command syntax. Router question mark. Yes, you can configure RIP OSPF EIGRP. So RIP version 2 network 200.200.200.0 network 10.1.32.0 network 10.1.23.0, no auto summary. Done. You can verify your routing table information. Show route. And yes, I'm receiving route information from R1, inside router, outside router, and DMG router. Clear this simple implementation? RIP configuration, everyone?
Yeah.
Okay. Let's go for next dynamic routing protocol implementation, EIGRP. EIGRP. So I'm trying to delete RIP configuration here. Clear. Configure router. Clear. Configure router. Let's go to the router device. I'm not using a router RIP. I'm trying to configure EIGRP. So router, EIGRP, autonomous system number, network, 200, 200, 200.0, and wildcard mask. We have a network 1.1.1.1, wildcard mask, no auto summary. Let's go to DMG router. DMG router. No router RIP. Now router EIGRP 10, network 10.1.32.0, wildcard mask, network 2.2. Yes, we have a loopback interface. 2.2.2, wildcard mask. Now no auto summary. Let's go to the outside router. No router RIP. Router EIGRP 10. 10.1.23.0, wildcard mask. And we have one loopback 3.3.3.3, wildcard mask, no auto summary. Let's go to the firewall device. Firewall device. Now, router, EIGRP, autonomous system number, network. I'm trying to advertise this 200 network. So 200, 200, 200.0. But now here's the difference. In root advertisement, here's the difference. In Cisco router, you can define wildcard mask to match your bit. Cisco ASA firewall device can't understand wildcard mask. Here, if you want to match any network bit, you can define mask here. Clear my point, everyone? There is no concept of wildcard mask in Cisco ASA firewall. If you want to match your bit, you can directly type your mask. Clear now my point? You can directly type mask 255, 255, 255.0. Done. Now network 10.1.32.0 mask 255, 255.0 network 10.1.23.0 mask. Now no auto summary. Done. You can verify route information, show route. Wait. See, we are receiving route information with D. What is D? D is what? Dual algorithm. D is what? EIGRP. Dual algorithm, diffusion update algorithm. What about OSPF? OSPF, let's delete EIGRP. Clear. Configure router. Now, no router EIGRP 10. And I'm trying to advertise all the devices, routers and firewall device. I'm trying to advertise all the devices in OSPF area 0. Remember, area 0 is called backbone area, transit area. So I'm trying to advertise all the devices in OSPF area 0. Let's go to the command syntax, router OSPF process ID. Now network 200, 200, 200.0 wildcard mask area 0. Yes, we have one loopback 1.1.1 wildcard mask area 0. Let's go to the DMG router, router OSPF process ID. network 200.0 wildcard mask area 0. Network 10 dot, oh sorry, this is TMG router, wait. Network 10.1.32.0 wildcard mask area 0. Network 2.2.2.2 wildcard mask area 0. Let's go to outside router. No router EIGRP 10. Router OSPF process ID. Network 10.1.23.0 wildcard mask area 0. One loopback we have here. 3.3.3 area 0. Let's go to the DMZ router. And I'm trying to remove EIGRP. Wait. Now let's go to the firewall device. Cisco ASA firewall device. So router OSPF process ID 200.200.0. Here is a no wildcard mask concept. We can match our bit with mask. So 255.255.255.0 area 0. Network 10.1.23.0 wild, not wildcard mask. Mask area 0. Now network 10.1.32.0 mask area 0. Done. You can verify now, show OSPF neighbor command. You have full agencies. Clear this routing implementation?
Yeah.
Routing implementation, everyone.
Yes.
Now let's talk about next point here, okay? Please wait 5 minutes, okay? I'm trying to prepare design. Okay, what I'm doing, I'm trying to delete OSPF protocol here. OSPF. So for basic connectivity, I'm using static and default routing into this design, okay? For basic connectivity. So from routers towards firewall device, I'm configuring default routing, okay? For any unknown destination, 200.200.1. Let's go to the DMZ router. For any unknown destination, 32.1 is the next hop IP. For any unknown destination, ten dot wait 10.1.23.1 is the next hop IP. Now let's go to the firewall device. For basic connectivity, I'm using static and default routing only. Okay. So route inside 1.1.1 for inside network. For DMZ network, I'm trying to create static routing. And for outside, I will configure default routing. So for 1.1.1 mask, next hop IP is 200.200.200.10. Root DMG 2.2.2.2 mask. Ten dot 1.32.10 root outside 3.3.3.3 mask 10.1.23.10 for basic connectivity. Yes, we have reachability. Okay, if you check here, If you go and check your connectivity, for example, from inside network, if I'm trying to ping 23.10, traffic is not traveling. Everyone remember? Traffic is not traveling. I'm trying to initiate my traffic from higher security level to lower security level. But this is ICMP traffic. I told you. By default, traffic is allowed from higher security level to lower security level, but only TCP and UDP traffic. So I cannot ping, but I can access telnet. Let's try 10.1.23.10. I can access Cisco 12345. Password Cisco 1. So we have basic connectivity into this design. Now let's focus on access list configuration. Let's focus on access list configuration. Everyone, can we start ACL discussion?
Yeah.
Can we take a break for 5 minutes, everyone? Okay, it's 9:08. Let's continue at 9:15, everyone. 9:15. Please turn off your mic. Everyone can hear me? Kash, Devanshu, Dushyant, Harshal, Moin.
Yes, I can hear you.
Now let's continue our topic now, everyone. So into this design, we can initiate our traffic from outside. We can initiate our traffic from inside. And traffic is traveling from higher security level to lower security level. But in case, if I'm trying to initiate my traffic, if I'm trying to initiate my traffic from outside, okay, I'm trying to verify my connectivity with inside IP, inside router IP address, I cannot ping. And if you remember, telnet is enabled here. Telnet is enabled. Telnet is enabled, but in case, if I'm trying to access telnet 200.200.10, I cannot access because by default, lower to higher, everything denied. Everything denied. In case if you want to allow your traffic from lower security level to higher security level, you can go with ACL concept. You can go with ACL, access list concept. Access list. Now, if you remember ACL concept in CCNA training, so we have two type of ACL implementation. If you guys remember, we have two type of ACL implementation. The first one is what? Numbered ACL. And second option is what? Named ACL. Numbered ACL and named ACL. Okay, you are configuring numbered ACL or named ACL. You can configure what? Standard ACL and extended ACL. What is the difference in between standard ACL and extended ACL? In standard ACL, we can filter our traffic based on source IP. We can filter our traffic based on source IP, source subnet, source network. In case if you want to filter your traffic based on source IP, destination IP, service or protocol, then you can go with extended access list. In case if you want to filter your traffic based on source IP, destination IP, if you want to check source IP, destination IP, service or protocol, so you can go with extended access list. In Cisco ASA firewall device, we cannot implement numbered ACL. We cannot implement the standard ACL. In Cisco ASA firewall device, you can go with named ACL, and in named, you can only configure extended access list. It means you can filter your traffic based on source IP, destination IP, and service and protocol. So into this scenario, we are trying to initiate our traffic from outside router. I'm trying to initiate my traffic from outside. This is our destination. Our source IP into this task, our source IP is 10.1.23.10. This is source IP. What about destination IP? 200.200.200.10. What about service and protocol? So telnet service. So we have three information right now. What is source IP? What is destination IP? And what is service and protocol? Service and protocol is what? Telnet. So outside machine cannot access telnet service because by default from lower security level to higher security level, everything denied. To allow your traffic, we can configure access list. And to configure access list, we have extended list option. And in extended list, we require three information: source IP, destination IP, service and protocol. And we have right now. We have source IP, destination IP, service and protocol. So let's go to the Cisco ASA firewall device. If I have all the information in traffic, source IP, destination IP, service and protocol. So let's go to the Cisco ASA firewall device. And now you can type access list. Command is what? Access list. If you type question mark, you can give name here. If you type number, it will take as a name. So I'm using a name, for example, outside, just a name, everyone. Outside, it's just a name. Now you can type question mark. You can decide your deny statement or permit statement. I want to allow some traffic, so I'm looking for permit statement. Now question mark, you can specify your protocol information. You can specify your protocol information. We are working with Telnet protocol, and Telnet is using what? TCP protocol. So we can specify protocol information here, TCP. Now question mark, it's looking for source IP. Firewall is looking for source IP. As per our task, source IP is 10.1.23.10. And this is specific IP address. So you can use host option, host command. Otherwise, if you type IP address here, 10.1.23.10. To match this IP, you need to define wildcard mask. But in Cisco ASA firewall device, we don't have concept of wildcard. If you want to match any IP, you can type mask directly here. Mask. So mask for this specific IP, mask is 255.255.255.255, single IP. Or you can go with host command. So TCP host specific IP 10.1.23.10. Now question mark. Firewall is looking for destination IP. Destination IP. So destination IP is host 200.200.200.10. Now equal to port number. So telnet port number. Can anyone help me? Telnet port number, everyone. Telnet port number. Can anyone help me? Telnet port number. Everyone, can you hear me? Everyone?
Yep.
Yes, Akash.
23.
Telnet port number is
23.
23. Thank you. So now equal to port number 23. You can type port number or you can type protocol name. You can press enter. Done. Your entry. You can verify now. Show run access list, everyone. Access list. Yes, we have a rule. Access list. Access list. This is ACL name. ACL name because it's a named ACL. Extended. Permit. Source. Source IP. Destination IP. And protocol information. Once you configure your access list, so you need to apply this access list on interface, just like a Cisco router. In Cisco router, if you configure ACL, you can go to interface, you can apply your access list. In Cisco ASA firewall device, yes, we need to apply. After ACL configuration, we need to apply this ACL on interface. And how to apply? What is command syntax? Command syntax is access group. In Cisco router, command is IP access group. You can go to interface, you can type this command IP access group. But in Cisco ASA firewall device, you are in global configuration mode. You can type access group command. Now question mark. You can define access list name here. Name of access list. So access list name is outside. Outside. Now outside in interface. And I want to apply on outside interface. Because as per our task, traffic will initiate. Traffic is coming from outside. So I'm trying to apply this ACL on outside interface. Done. Done. You can verify now. I'm trying to initiate my traffic from outside. Let me check telnet password here. CCIE123. Okay. So I'm trying to initiate my traffic again. This traffic again. Telnet 200.10. And yes, I can access. See, password CCIE123. Wait, CCIE123. See, inside router. And if traffic is traveling through the firewall device, so you can verify session table information, show connection. Yes, traffic is initiated from 10.1.23.10. Source port number is a random port number, destination IP, and destination port number. Rupesh, clear? Rupesh, clear for you? This is ACL configuration, everyone. This is ACL configuration. Now, I'm trying to exit this. Wait. Exit. And you can verify your connection table information. So traffic is not traveling through the firewall device. Yes, Dushyant, any question?
Yeah, just one thing. Can we verify these ACLs once we have created?
Yes, see. Show access list. This is ACL entry. And right now you have a hit count one hit count right now. If you initiate your traffic again, password CCIE123, you can verify your hit count this time. Now you have hit count 2. So you can also monitor. Question. If someone will hit on your policy, you can also monitor hit count.
That's cool. Thank you.
Okay. So now here we have entry. Now let's verify. Wait. Exit. So now show connection. Show connection. So traffic is not traveling through the firewall device. So we don't have any entry in connection table in session table. This is what our access list configuration. Access list. Yes, we can create multiple ACL route. We can create multiple ACL route, but we can configure, we can create in NAT topic. In NAT, I can tell you how to configure multiple access list rule. So ACL and NAT. This is our topic for today and tomorrow. Wait. So we can create multiple access list too. But before ACL configuration, multiple ACL rule configuration, let's talk about NAT first. NAT, network address translation. Let's talk about NAT. Any idea about NAT, everyone? Any idea about NAT?
Yeah, NAT is short for network address translation,
Okay.
and it is used to translate from private to public or public to private anything.
One IP into another IP.
Yeah, one IP into
One
another.
IP into another IP, Dushyant. Okay, it doesn't matter. Okay, it doesn't matter. Traffic is traveling from private to public. You want to translate private to public, public to private, or private to private, or public to public. It doesn't matter. Okay, NAT we are using only for translation. Okay, so let's talk about a scenario. Wait. Let's talk about scenario. I have one firewall device. So I have one L3 device. Wait. Any netted device. Okay, for example, router here. This router is connected with LAN side portion. Your inside network. Inside network, you have multiple computer this side. Now this portion is your ISP side. This portion is your ISP side portion, ISP side network. No. So this portion is your LAN side network. LAN side network. This portion is your ISP side network. In LAN side network, in private network, I'm using private IP. For example, 192.168.10.10, 10.11, 10.12, 10.13. So in private network, I'm using private IP. In LAN side network, I'm using private IP. If this 10.10, for example, if this 10.10 is trying to communicate with internet, okay, trying to access internet services, trying to go on public side network. So you need to translate. You need to translate this private IP into public IP. This private IP into public IP. And for translation, we have a topic NAT. For translation, we have a topic NAT. In NAT, we have translation configuration option. We have translation configuration option. We have static NAT. We have dynamic NAT. Or we can go with PAT option, port address translation. What is a static NAT? What is static NAT? Static NAT is called one-to-one mapping. Everyone, one-to-one mapping. For example, in your LAN side network, you have 10 computers, 10 private IPs. Then you need 10 public IP, 99.99.99.1.2.3 and so on, .10. So for 10 private IPs, you need 10 public IP. And I'm looking for static NAT option. So in static NAT configuration, you need to create all your translation entry. You need to create all your translation entry statically, manually into this netted device. Wait. Okay. So in static NAT, you need to create all translation entry statically, manually into this netted device. For example, this 10.10, I can map. This 10.10, I can map with this 99.99.99.1. This 10.11, I can map with this 99.99.99.2. This 10.12, I can map with this 99.99.99.3. So when this 10.10 is trying to travel outside, it can get this public IP and traffic is traveling outside. The static NAT is bi-directional, everyone. Only static NAT. Static NAT is bi-directional. Bi-directional means what? In case if this inside machine, this 10.10 is trying to travel outside, as per your static NAT configuration, this private IP is mapped with this public IP. This private IP is mapped with this public IP. So as per static NAT, whenever this 10.10 is trying to travel outside, it can get this public IP. Traffic is traveling to outside. But as I said, static NAT is bi-directional. Bi-directional. It means if anyone from outside will hit on this public IP, So as per static NAT entry, your firewall will redirect this traffic on 192.168.10.10 as per static NAT entry. So static NAT is bi-directional. Now in static NAT, we need to create all translation entries statically. For example, if I have 1, 2, 3, or 2 or 3 computers or servers, yes, I can go with static NAT, no problem. But if I have multiple computers in LAN side network, for example, I have 100 computers or 200 computers in LAN side network, 200 computers, then if I'm looking for static NAT configuration, first I require 200 public IP. If I'm looking for a static NAT, I need 200 public IP address or 200 private IP address. And static NAT, we need to create all translation entries statically, manually into this netted device. It's a difficult task. If I'm working in a big network, a static NAT entry is a difficult task. That's why we can go with dynamic NAT implementation. Dynamic NAT. Yes, for 200 private IP address, I need 200 public IP. Yes. For 200 private IP address, I need 200 public IP. But this time, I'm not creating 200 entries statically, manually into this NAT device. No. No. In dynamic NAT, with the help of single command, you can create a range of public IP here. You can create a range of public IP address into this netted box, into this router device, with the help of single command. You can create a range of public IP, pool of public IP. So now this time, if anyone, for example, if this 10.10 is trying to travel outside, it can get any IP address from this pool range and traffic is traveling to outside. 10.11 is trying to travel outside, it can get any IP address from this pool range and traffic is traveling to outside. It's a dynamic NAT. But again, we have an issue. Again, we have an issue in static NAT and dynamic NAT. For 200 private IP address, I need 200 public IP. This is the issue. For 200 private IP address, you need 200 public IP. That's why I'm not using static NAT and dynamic NAT in a big network. That's why I'm looking for PAT configuration. I'm looking for PAT. Wait. So I'm looking for PAT configuration. In PAT, you can translate multiple private IP address. In PAT, you can translate multiple private IP address with single public IP. Okay, this is your public facing interface. This is your public facing interface, everyone. For example, I'm using 99.99.99.100. So in PAT option, we can translate multiple private IP address with single public IP. If 10.10, if 10.10 is trying to wait. If 10.10 is trying to travel outside, okay, this 10.10 it will get same public IP, traffic is traveling. If 10.11 is trying to travel outside, it can get same public IP, traffic is traveling to outside. What about packet format? What about packet format? Okay, for example, wait. For example, we have server this side, outside we have a server 8.8.8.8, for example. And both 10.10 and 10.11, they want to communicate with 8.8. They are trying to access same destination. They are trying to access same service, for example. Then what about packet format? What about packet format? Wait. Now, so 10.10 is trying to communicate same destination 8.8.8. So source IP. Wait. Source IP, source port number, destination IP, destination port number. Source IP is 192. As per our task, 168, 10.10. Source port number 52,000. Destination IP is 8.8.8.8. Destination port number is 443. Now 10.11 is trying to access same destination. So source IP, source port number, destination IP, destination port number. Source IP is what? 192, 168, 10.11. Source port number, any random port number we can take 52,008, for example. Destination IP 8.8.8, destination port number 443. So 10.10 and 10.11, they are trying to communicate with same destination. They are trying to access same services. So when traffic will go and hit on this netted device, then firewall, this netted device will create an entry first. This router will create an entry first for this traffic. And once it will create an entry, after that, it will remove this source IP information. It will remove this source IP information. It will put this outgoing interface IP address as a source. Outgoing interface IP address as a source IP 99.99.99.100. And this traffic is traveling to outside everyone. Public IP is communicating with public IP. Now, what about 10.11? Traffic will go and hit on this netted device. Router will create an entry first. After that, router will remove the source IP address information. It will put this outgoing interface IP address as a source IP 99.99.99.100. And this traffic is traveling to outside. Everyone, can you hear me? Rupesh, Wes,
Yes.
Tesh, Moin, Harshal.
Yes.
Yes.
Now, what about reply packet, everyone? What about reply packet? When 8.8.8, my point is, when 8.8.8 will send a reply packet. When reply packet will hit on this router, then how your router will identify this reply packet is for 10.10 or this reply packet is for 10.11. Any idea?
Maybe make some entries on the table with the specific source port.
Source port, perfect, yes. Based on port number, yes. Port number. Based on port number, this netted device can identify the traffic. Okay, router can identify, okay, this is into this traffic, because into this scenario, you are only translating source IP. Rest information is same. You are translating only source IP. So now when 8.8.8 will give the reply packet, will hit the reply packet on router. Router will check port information. Based on port information, this reply packet, firewall will send on, for example, firewall will send on 10.10. This is our NAT concept. This is what? Basic NAT. This is what our basic NAT implementation, CCNA training, CCNA topic. If you go with the firewall device, in firewall box, we have two type of NAT implementation. In firewall device, we have two type of NAT implementation. The first option is source NAT implementation, and second option is destination NAT implementation. So we have two type of NAT implementation in Cisco firewall, in any firewall device. Now, what is source NAT and what is destination NAT scenario? So this one is a good example. It's a great example for source NAT implementation. This one is source NAT implementation, everyone. Whenever you are translating your source IP, it's called source NAT. What we are doing into this scenario, this 10.10 will hit on router device. Router will create an entry first. It will remove the source IP. It will put this outgoing interface IP address as a source, and traffic is traveling. So whenever you are translating your source IP, this is called source NAT. Source NAT. It means this is static NAT. It means your static NAT, dynamic NAT, and PAT option. These are source NAT source NAT implementation option. Pat, these are what? Source NAT implementation option. Destination NAT, we will discuss tomorrow. Okay, everyone?
Okay.
Destination NAT, let's continue this topic, this training, tomorrow, same time. Okay, please connect at 6 p.m. This session recording, I will share with you tomorrow. Okay, Moin?
Thanks.
Okay.
Let's continue our session tomorrow, everyone, same time. Bye, guys. Take care. Good night, everyone.
You too.
Good night.
Good
Bye-bye.
night, everyone.
Thank you.
Bye.